Good morning, students. My name is Dr. B. Suresh Babu, working as a professor in Mechanical Engineering Department in MBR College of Engineering and Technology, Paritala. As a part of online classes, today concept is on Unit 4. Up to now, we have discussed first, second, and third units. That is the one part of the syllabus. If you observe the syllabus of 4, 5, 6, it is another way. In all 1, 2, 3, it is a manufacturing techniques we have discussed for composite materials. We have discussed a manufacturing technique of reinforced composites. We have discussed manufacturing techniques of plastic composites. In fourth unit, basically, it deals with the analysis of the materials. If you observe the title of the fourth unit, it is Macromechanical Behavior of Lamina. Try to understand macromechanical behavior of lamina. What is its meaning is, first of all, what is a lamina? A lamina is a rectangular object having a nullified thickness. That means if the thickness is going to be very minute when compared to the length and breadth, then we are going to call it as a lamina. Next, it is a behavior. Behavior means in the response of a material when loads are going to be act on a, it is going to be called as a behavior. So there are different types of loads will be there and different types of forces will be acting on that one. So this behavior, how a lamina will act when a different forces are acting on it, we are going to learn here. Next, up to what extent we are going to learn, they have clearly mentioned we are going to learn the mechanical behavior only. What is meant by mechanical behavior? There are number of properties are there in mechanical engineering, like hardness, shearing, brittleness, ductility, creep, corrosion. Like this, there are number of mechanical properties are there which we are going to behave when the forces are going to be act on a lamina. So that is the next. Up to what extent you have to study? You have to study at the macro level, at a molecule level you have to study. So this is the title of the fourth unit. That means the title subtopic is we have given macro mechanical behavior of a lamina. We are going to study the mechanical properties when the forces are act on a lamina. Lamina is nothing but a physical object having minute thickness when compared with length and breadth. The up to we have to concentrate on the macro level only. So that is the thing to be understand here. How many types of behavior will be there? There are physical behavior will be there. Physical behavior in the sense the change in shape, change in size, change in orientation will be treated as a physical behavior, or change in position. Or chemical behavior, physically we cannot able to observe few things outside the object, but internally there is going to be a change in the molecule size due to the forces that are going to be act on the lamina. So that is one type of behavior. For few objects, it, the behavior may be in diminishing in one part of the size when compared to other part due to the forces acting. This also comes under physical behavior. So this is how, up to what extent you have to study means the concentration should be on the at the macro level only. That means at a molecular level you have to study. That is the thing to be understand here. Next, syllabus. The syllabus for the Fourth unit they have given is introduction, generalized Hooke's law, reduction of Hooke's law in 3 dimensions to 2 dimensions, relationship of compliance and stiffness matrix to engineering elastic constants of an orthotropic lamina and laminate core. So this is the syllabus that is given to understand. Now the present session is on introduction of this introduction of the fourth unit and explaining about the Hooke's law. So what is the aim of the class is introduction about the fourth unit and generalize the Hooke's law. What the Hooke's law says. In introduction, already I have explained in a very brief manner. Let us go into the detail. If you observe this, a material is going to behave in different directions based upon a medium that is present. It means a material is going to exist in one medium, and that medium is going to be have a one type of orientation. The orientation may be x, y, z, or it may be clockwise, anti-clockwise. It depends, and the properties are also behave in the direction. Then that is going to be called as a behavior of a material based upon the medium. For example, how many types of medium means if we observe, liquid medium is there, solid medium is there, and gaseous medium is there. If you take a liquid medium, liquid metals can be compressed up to certain extent. Gases can be more compressed than compared to the liquid medium. Solid medium cannot be compressed unless if it is a rubber material we can able to compress. If the solid brittle material like a glass we cannot able to compress that one also. So the behavior of a material will be in a particular direction, and that medium is going to be called as a anisotropic medium. That means the material whose percentage properties or direction depend is called as anisotropic medium. I repeat once again, what is anisotropic medium? The material whose percentage properties or direction depend is called as a anisotropic medium. Fully anisotropic mediums are usually not found in engineering applications. So this is how we can able to explain the material whose percentage properties are direction dependent is called as a anisotropic medium. If we take liquids cannot be applied tensile stress. On gases also tensile stresses cannot be applied, but on a solid medium we can able to apply the tensile stress. So that solid medium is going to be called as a anisotropic medium. Plasma medium is there. On the plasma we can able to compress, like toothpaste we can use, gel can be compressed to some extent. Gases can be more compressed. So this type of behavior, that means if a medium behaves on a direction dependent, that is called as a anisotropic medium. Next one is a fully anisotropic materials are usually not found in engineering applications. It is a caution that no material does not no material does not behave like a perfect in terms of their applications. So fully anisotropic materials are usually not found in engineering applications. So materials are going to be used in engineering applications. For example, a car is there. Car can be used for transporting the materials. For applying the brake pedal is going to be used. In the brake pedal we have shoes will be there, brake shoes will be there. So brake shoe, it's try to restrict the speed of the vehicle, but it cannot 100% fitted to that one. Gradual it is going to be stopped. Like that, the material application is limited to certain areas for 100 kgs or 200 kgs. More than that means you have to increase the size and shape. Like that, a limitation is there for any material. That limitation says that fully anisotropic materials are not found in engineering applications. Next, the simplified form of anisotropic characterized by the presence of planes of elastic symmetry is open found. The simplified form of a anisotropic characterized by the presence of planes of elastic symmetry is open found. What is the meaning here? So if you want to understand the characteristic of anisotropic materials, the presence of planes is going to be symmetry. That is the thing. That means if you take a pen is there, pen is going to behave in a symmetrical manner if loads are applied on a tensile direction. The same material behaves when the loads are applied in a compressive tensile compressive type of stresses. So that is the thing to be understand here. Next, a simplified form of anisotropic characterized by the presence of a planes of elastic symmetry is open found. Next, as the number of planes of elastic material increases, the number of independent elastic properties required to characterize the material reduces. What is this means? For example, a plane is there. Here it is in the form of a round shape. In the form of a round shape. If you observe this one, there are how many planes are there means, so how many edges means we cannot define clearly. But specifically we can hold on the outer edges and we can apply tensile stress. Then the behavior of the pen will be in one way. If number of planes are there, if you take a square lamina, or if you take any object which is in the form of a square, if you say this is a plane material, how many edges are there? This can be one direction, this can be another direction, and this another direction. So that means as the number of planes of symmetry increases, the number of independent elastic properties required to characterize the material reduces. That means independent property cannot be found because the material behaves in multi direction. If number of planes are there, when pin is there, it can able to sag in this direction only if you apply the load, because if you apply in this direction there is no proper edge, but in this here that is not the case. So it can able to do like this, it can able to do like this. So this shows that the number of planes of elastic material increases, the number of independent elastic properties required to characterize the material. Next, starting with fully anisotropic medium, the consecutive relations are stated without presenting formal derivations for different materials in order to reduce anisotropy. What is the meaning here? If you observe the starting with fully anisotropic, if you take a material, that means anisotropic medium means the medium which behaves based on the direction dependent. The consecutive relations are stated without presenting formal derivations for different material. That means derivations are going to be in one order, that is going to be reduce the anisotropic character of this direction. Next, later these relations are particularized to the lamina. So what is a lamina? A lamina is a physical object having less thickness. If you observe this one, number of planes are going to be acting on this one, on this object. This is one plane, another plane. So if number of studies are increased and these are particularized to one, then that is going to be called as a lamina. So what is this slide includes is This slide includes, we have derived the, we have studied the definition of a anisotropic medium. The medium that is depend upon the direction is called as a anisotropic property that depend upon direction of a medium. Next, no material is fully anisotropic condition based upon the engineering applications are concerned. If number of planes are there, it is reduces the to study the characteristics of that material. So this is basic points to be remembered from this slide. Next we will go for another slide. Already I told in the beginning of the class, when material behavior can be studied, when we applied a certain external load on that one, we can able to study the material behavior. So what are the loads we can add? The load is nothing but the force acting on that one. Here I have taken a stress. Stress is how a stress can be defined. Stress is equal to force by area. So what is the force by area? In how many ways force can be applied? Force can be applied in different ways. For example, two forces are acting on object in opposite direction against each other, then that is going to be called as a tensile stress. If a force are going to be acting one against each other on the same object, then that is going to be called as a compressive stresses. If forces are acting on the an opposite direction on the plane, that means one acting in this direction and second acting in this direction, then on a plane object, then that is going to be called as a shearing force. So this is how broadly a forces can be. Sometimes number of forces can be acted on the same object in different directions. Then what happened? The material is going to be deformed in different ways. Whichever is the larger force, in that way the reaction is going to be high when compared to the other one. So like this, if you observe this one, as per the basic definitions, if number of forces are going to be acting, the resultant of these forces direction will give the deformation of the object. So that is the thing to remember here. If you observe this, when a body stress, when a body is subjected to external forces, equal and opposite forces are going to be opposite, equal and opposite forces are going to act on that one. Internally, body is going to exhibit some of variations. The variations may be, sometimes molecules may expand, sometimes molecules may compress. It depends upon the type of force we are acting on that body. This resisting force is known as a unit stress or a stress. So this is the thing to be understand. Stress is equal to force by area. For the first, we have to remember that one. If a large force acting on a large area means the force is going to be nominal. If a large force is acting on a small area means stress is going to be very high. If a small force acting on the large area means stress is going to be very low. So this is the broad idea we have to remember for a stress. Stress is equal to force by area. That is P by A. A is the cross-sectional area of the element or lamina, whatever we have chosen, and force is the in newtons. Now stress is generally denoted by a Greek letter sigma. In system international units, SI units, the units of stress is Pascal. 1 Pascal is equal to 1 Newton per 1 square meter. In a practical calculation, bigger units like megapascal can be considered, or if still it is bigger in value, we are going to consider the gigapascal. 10 to the power of 6 is megapascal, 10 to the power of 9 is the gigapascal. So this is a stress. That means when a body is subjected to external forces, the forces may be a compressive forces or expansion forces or in multidirectional forces. So if you take in multidirection forces, the resultant of all forces direction, in that direction only the deformation takes place. There are number of elements will be present in a material. All the elements does not behave in a same direction. The behavior of a material will depend upon the forces that are acting on that one. That is the first point. If those forces are acting in one direction means in that direction only metal try to expand or metal try to compress. So that forces are nothing but a load we can act. If you take a spring, if you are expanding means there is a direction. Like that we have to remember here. Okay, this is how a stress can be defined. Next one is a strain. When a body experiences a system of force, some deformation, that is elastic or plastic, takes place. This deformation per unit length of the body is known as the unit strain or simply strain. What is a strain? Strain is equal to change in length by original length. That is how the strain can be defined. When the strain takes place when a stress is acting on the body. Stress means when forces are acting on a body, that body tries to deform. The deformation to its original dimensions will be defined with the help of a strain. For example, a pen is there. If a pen, I am going to apply tensile strength. Say this length is around 15 centimeters. When load is applied, so these edges are trying to expand. It expanded to 18 centimeters. So what is the change in length? Change in length is 3 centimeters. That is originally it is 15. Now it is due to the force it has turned to 18. So change in length by what is the original length is 15 centimeters. 3 centimeters by 15. This is called the strain. How the strain acted on that one? To strain takes place due to the stresses acting on the object. How many types of stresses are there? If you observe this one, in this particular case, I have applied the tensile stresses. So if you try to compress this one, that is compressive stresses are acting means it is 15 centimeters. It is diminished to 14 centimeters. So 15 minus 14, that is the change in length is 1 centimeter compared to its original length is 15 centimeter. This is also a strain when the forces are acting in a compressive direction. Next, shear stress also same thing. What is the shear stress? The forces are acting on the top surfaces only in in opposite directions or like a compressive force in same direction. Then also the strain will takes place. So what is the strain means? Change in length to its original length is going to be called as a strain. Strain is generally expressed by the Greek letter epsilon. Epsilon is the symbol. It is similar to the E, but a slight change is there. I will show in the coming slides. Um, so if we observe this one, stress is equal to force by cross sectional area. It is represented by the letter sigma. Strain is a change in the length of the body to original length. It is expressed by epsilon. So this is how the stress will be two forces P which are acting on a yellow color object in opposite directions. Due to that one, there may be a change in the yellow color that is shown with the help of R, and that leads to the change in shape, change in size, and sometimes change in position also it will take place. If one P has higher value and compared to other P, then there is going to be a change in here. So The sigma is the symbol, whatever sigma is equal to resistance of force by cross sectional area, that is P by A. So within a certain limit, elastic limit R is equal to P. When force is increased means R does not going to be matching with P means the material is going to behave in different manners. So material means how many types of materials are there? The materials are going to be broadly brittle metal will be there, ductile metal will be there. So if based upon the forces the metal is going to behave, that behavior will define the property of that material. That's what you have discussed in this class. Our what is the aim of the class is introduction about the materials, about exclusively on behavior of a macromechanical nature. We are concentrating on Hooke's law. Hooke's law states in the coming slide. I will say this is all about introduction. So, how Hooke's law is related to first of all stress. That's what I have to explain. Stress I have defined. Stress is equal to force by area. How many types of forces are there? I have defined. It may be tensile forces, or it may be a compressive forces, or maybe shear forces. Force is nothing but the an external load but acting on an object will change a position of the object due to that external load. So that's what we are discussing here. In which way to direction means the resultant of the force is the direction in which the material tries to change its orientation, position, or its dimensions. Next, if you observe the first figure, tensile stresses, two arrowheads are acting in opposite direction, one with respect to each other. Then that is going to be called as a tensile forces. What is compressive forces? If we observe two materials that are going to be act opposite, one against each other on object, then that is going to be called as a compressive forces. Like that, if these are going to be acting here in one direction, another force is acting here in the plane parallel to this one, then that is going to be called as the shear forces. So first stress is a tensile will be there, compressive will be there, shear stress will be there. This is how the forces. Based upon this one, what happened? The body may change its size, shape, and orientation. That orientation change is going to be called as a strain. So that's what I want to explain here. I want to explain introduction of this unit. Whatever the material, when stress is applied and there is going to be the change in its position. Stress is nothing but a application of a load. How the material behaves, that we have to understand here. If you observe this slide, it's a very important diagram. Stress versus strain. If you observe, 5 points are mentioned: A, B, C, D, E. What is the importance of these 5 points? For example, A point, that is proportionality limit. If you observe this indigo color line, if a material is faced external load up to A point, and if you remove the load at A point, the material tries to regain its original position, shape and size. Original position in terms of shape and size, then that limit is going to be called the proportional limit. That means up to a material can able to regain its own structure. If you add a little bit excess than a type of load, then we are going to face elastic limit. That means beyond that elastic limit, regaining of original character of the metal is not possible. That's how the shows. That means B is elastic limit. That means here the Hooke's law comes. Within the elastic limits, stress is directly proportional to strain. That means what is the stress? Force by area. We are going to apply the load and strain is going to take place. Beyond that B, if you apply the load, means the material lose its nature, lose its character to some extent. That means it will change its position and will change its orientation. Then that is going to be called as a yielding point. That means beyond C, if C, beyond C, if load is removed also, the material cannot regain its original shape and size. After C also, if you add load, the material is going to be deformed continuously, and the deformation is going to be called as a plastic behavior. So from C to D, the material we are going to apply the less load only. Still the material will change its position or change its orientation in a quick manner. That means from C to D, the behavior of the metal will going to be called as a elastic behavior. From A to O, we are going to be call it as a elastic behavior. Permanent set means of beyond B. If you apply load, there will be a change in permanently in terms of characteristics of a material. Then that is going to be called as a permanent set. Next, compared to D and E. After D also, if you apply the load, the material is going to be fractured. If you observe the clearly E point, D2 is in decreasing. That means stress is low. Still the metal is going to fail. Here I have to explain 2 points. One is ductile material, second one is about brittle material. Brittle material fails suddenly. Ductile material fails by giving a warning. So D is going to be the ultimate strength, we can say, ultimate stress. At ultimate stress, brittle material is going to fail without any give warning. But ductile material, by removing that load also beyond D, without applying load also, the metal is going to fail because metal lost its nature. That's what the meaning is. Next, what the Hooke's law says? Hooke's law says within the elastic limit, stress is directly proportional to the strain. That means beyond the certain point, if load is applied, the material lost its nature. Then the material does not obey the Hooke's law condition. If you observe, stress is the force of unit areas within the material that develops as a result of the externally applied force. Strain is a relative deformation produced by stresses. For relatively small stresses, stress is proportional to strain. Already we have discussed this one. Within the elastic limit, stress is directly proportional to strain. For a small stresses, material will be within the Hooke's law condition. For a large amount of stress is there, then material is going to behave in a different manner. The different manner we have to study in the coming classes. So this is about the Hooke's law. So Hooke's law states that stress is proportional to strain within the elastic limit of the material. When elastic materials are stretched, the atoms and molecules deform until the stresses is being applied, and when the stresses is removed, they return to their initial state. Mathematically, Hooke's law is commonly expressed as F is equal to minus Kx, where F is the force, X is the extension length, and K is the constant of proportionality known as the spring constant. This is a mathematical relation to understand how the Hooke's law can be commonly expressed. So ultimately, Hooke's law is says if stresses are small, the material is going to be behave within the elastic limit only. If stresses are going to be large, the material deforms or loses its original nature. So these are the few examples to understand behavior of a material. Here I have expressed five materials. One is steel, plastic, rubber, and next one is gels or biological tissues. So this, if you observe this one, Hooke's law is equal to sigma is equal to E into epsilon, where E is equal to sigma by change in length, that is nothing but strain. So E is equal to stress by strain. So within the elastic limit, the Hooke's law is going to be applied. For example, steel, if large force is applied, then the deformation is going to be very small, because this is the strain and this is the stress. Large force is applied, but change in length is very small. If we observe, stress is low compared to steel material, but strain is going to be high. For a rubber, for small stress only, the change in length is very high. In the gels, if you take change in length is very large, but stress applied is going to be limited when compared to the remaining three. That means Hooke's law E is nothing but the elastic limit, elasticity. Sigma is equal to P by A epsilon. This is called epsilon, that is change in length by original length. This is how we can express the importance of the Hooke's law. If you observe, the E is one nature of steel, this one is plastic, rubber, and this is gel. So the aim of the class is introduction about the fourth unit. What you have to study in introduction? First one is what is anisotropic medium? That means the medium that depend upon the direction of a material when properties has to be studied. That means the properties has to be studied based upon the direction of a medium, that is called as a anisotropic medium. No material has 100% anisotropic character, that is second nature. Third one, if a plane lamina has a number of planes, then to study the elastic nature, the parameters are going to be decreased. This is the three important facts. Next, I have defined the stress and its unit, strain and its unit. Stress is force by area. Unit is megapascal, gigapascal, or pascal. Next, strain. Change in length by original length. It has no unit. It is represented by epsilon. Next, the aim is Hooke's law. So within the elastic limit, stress is directly proportional to strain. How the Hooke's law will applicable, that I have explained with help of these five types of material. You can have a doubts to my mail ID, that is seed5@rediffmail.com. Thank you, students. The unit notes will be provided within 3 to 4 days. For 1 to 3 units, the complete notes is available in Google Classroom code small g m t k r t q. Thank you, students. See you all. Bye. Have a good day.